Yeah, physical science learners and teachers, we are on the section of electrodynamics, which is the part of electricity sections, electricity in the electrodynamics, electricity and magnetism. In this section, we'll be dealing with two things. One is going to be motors. The second one will be generators. Now, the simple difference between the two machines, it's in a motor, we are converting electrical energy to mechanical energy. And in the generators, we are converting mechanical. If you've forgotten this, just remember the wind turbines, mechanical to electrical energy. Now, the principles that are used beside this energy conversion, then we say these motors are using the motor effect, which is not examinable, and then the generators are using electromagnetic induction. Very important. Electromagnetic induction. Electromagnetic induction. I will explain how these things works when we'll be using the Fleming's right hand and the left hand rules. The other difference will be just the parts. We have got the parts of motors and generators. Motors or generators, they are almost the same. The difference is just the output. The arrangement will be the same. Let's start with the DC motor or a generator. We'll talk about the AC ones this side. And now the difference will be in a DC motor, we'll be having the magnets, which is north and south. We'll have a coil in the magnetic field. Either it's going away from the observer, which is this one, or towards the observer when you see the point. I hope you remember that directions. And then in this one, we'll be having the rings, which are split into two halves. Then this is called the split ring. And this is called split ring commutator. Whereas these ones are the carbon brushes. Brush. We'll talk about their usage, and then in the AC we'll be having north this side, south this side, therefore also having a coil with the current facing or moving away from the observer. Then the arrangement in this case will have two continuous rings with their respective brushes. These are called slip rings. These are still brushes. This one is an armature. This is the armature or the loop armature, or just a loop or a coil in that case. Now let's go to what is the use of these two. Now the brushes, they can ask you uses here of the carbon brushes. Carbon brushes, this ones they just connect the external circuit with the commutator in the case of DC, or with the internal circuit. We can just say internal circuit. Circuit is fine. Now, whereas the split rings, main use here is to reverse the current in every 180 degrees or semicircle. This is what will be happening in a nutshell. After every 180, the current will be reversed. If this is the current and this is the time, then this will be the case of voltage or time. The current is reversed every 180. Whereas the slip rings, remember this one is a commutator. You can write the word commutator, it will be okay. And the slip rings, this one alternate the current, and that it changes the polarity of the current in every 180 degrees. What happens in this one will be having this type. So the current in every 180 degrees will have to change the polarity from positive to negative. That's why we say this is the AC, which means that now it changes the direction continuously, constantly in this case. From this one, we'll talk about the maximum and the minimum EMF according to the Faraday's law. Faraday's law in grade 11 helped us to talk about the maximum and minimum. Let's entertain the maximum and minimum EMF. When is maximum or minimum EMF produced? When the coil is rotating in the magnetic field. Minimum EMF or current. Now, from the information that we have, we know that now in grade 11, when this is the arrangement, when the coil is horizontal, that now the coil is horizontal here, and which means that now the field will be perpendicular to the area of the coil. Then we say now the phi will be maximum. In this case, maximum, remember we say phi is maximum when the field is perpendicular to the area. That's what we learned in grade 11. Therefore, at this position of horizontal, the EMF that is induced will be maximum. Now, on the other side, we'll be having the North Pole and the South Pole. And we have a coil now which is vertical. Now this is vertical, that one is, this one was horizontal, this one is the vertical. When the coil is at vertical position, say the field here will be sort of parallel to the coil. As a result, if you go back to grade 11, it will be now perpendicular to the normal to the conductor. Therefore the phi, if we use the BA cos theta in grade 11, we know that if the angle is 90 degrees, then cosine of 90 degrees is 0. Therefore it means that the phi will be cosine of 90 degrees is 0. Therefore the phi will be 0, which is the minimum. Therefore minimum phi, minimum EMF. So in this case, if you are requested to draw, let's say for example they request you this question to draw the EMF starting from this position, the current time graph or the voltage time graph. There are two versions for a DC generator. Let's say we talk about generators here. DC generator, when you draw from this position, horizontal position, you will have this. It will start from maximum, minimum. This will be the case, and then you will end this way. This is the graph of current versus time, or voltage versus time, when the coil start from this position, horizontal position. And then if